So let's talk about the two ways that we can view our study of the earth, okay? First one is called uniformitarianism. That is number 2. Uniformitarianism. It's the doctrine that says that the present is the key to the past. So that says, for instance, we're going to learn about what's called continental drift. That is the idea that the continents are drifting several millimeters a year. And so if you calculate that out, the continents came apart over a period of millions and millions of years. Okay? By claiming this, they're saying there's no difference in the change over time. If you go to visit the Grand Canyon, they will tell you that it took 70 million years for the Colorado River to make the canyon. All right? That's uniformitarianism. Catastrophism is the next word. Catastrophism. Now, what do you see in that word, catastrophism? Yeah. Catastrophe. Right. Catastrophe. The doctrine that sees evidence that rapid, highly energetic events operated over short periods of time and did much geological work rapidly. In this view, the Grand Canyon was carved out quickly by volumes of water rushing rapidly over the ground. For me to help you to be truly educated is for me to teach you both sides of the coin so that you can decide what you believe, but you can know why you believe what you believe. So let's take a look at the biblical view. We're going to start out with the biblical view. Now, Christians believe by faith that the true history of the earth is written in the Bible. And it starts with, in the beginning, God. And really, that's where our faith really starts. In the beginning, God. In the beginning, God. And it says that he formed the oceans and then the continents. He placed plants and living creatures. Finally, he created man to be stewards of the earth, to keep it and use it wisely. I think we failed in that area in a lot of ways. A lot of people say, well, Christians aren't environmentally minded. We should be, because God called us to care for the earth. That means that we should pick up our trash, we should recycle, we should do the things that we can, turn our lights on. We can do the things that we can do to help our earth be a better place. But God said in the beginning that it was very good, perfect, and it would have lasted like that forever. But now we see that earth isn't quite so good, okay? Things go wrong here. We have all kinds of problems, natural disasters, earthquakes, hurricanes. We have sickness, illness, cancers. These were not part of God's original plan for creation. So what happened? Well, we know what happened. Who can tell Miss Debbie what happened? What happened? Yes. Sin. Sin came into the world. And you know, I could point to Adam and Eve and say, meh, meh. But if they hadn't, I would have probably. I mean, that's the reality. Because the scriptures say that all of us sin and fall short of the glory of God. All of us. There is none of us without sin. And in Adam's day, there was a penalty for sin. And the entire creation was placed under a curse. The entire creation. That's why there is death. So a lot of people will say, well, God started evolution. Well, if that's true, then death had to come before Adam. Death would come through natural selection. The survival of the fittest is the one that survives. So death would come through you not being able to survive, because you didn't have a fully developed body. And so death would come through natural selection, not through sin. So we have a problem with that. You have a problem because the Bible clearly states that death comes as a result of sin. And sin, it says, by one man came sin, and by one man came redemption for all humanity. So, you can't say that God started evolution, because then this doesn't work. It just doesn't fit. The other thing, says 24-hour day. There's different words for day in Hebrew. The word for day in Genesis is a 24-hour period day. It takes faith for us to believe that he created all this in one day. But it takes faith for me to believe otherwise. Because here's the deal. Anything from a historical perspective like that cannot be absolutely proven. How can we prove exactly what happened? We can't. We can look at the evidence and we can think, this could have, that could have. But we can't prove it any more than they can prove it. We believe by faith, you see? That's what separates us. That's what separates us. But that doesn't mean that we just don't use our minds. We say, okay, we believe by faith, so we don't have to think about it. I think we should think about it. Because we need to give testimony. Now, there was a scientist by the name of John Clayton, and he decided he was going to set out to prove the Bible wrong. And it often happens. He, instead of disproving the Bible, came up with a new verse. And that happens over and over. Some of you have seen Case for Christ, those movies. Amazing, amazing. But he wrote a book called The Source, and I want you to look at Exhibit A. Look at these odds in Exhibit A. The odds of the earth possessing the necessary conditions to support life by chance. If things happen by chance, you're a cosmic accident. Everything you see here is an accident, right? You're just an accident. Is that what you want to be? An accident? Or do you want to be created by God, chosen by him for a purpose? Being in the right kind of galaxy, 1 in 100. Being in the right place in the galaxy, 1 in 150. Having the right kind of star, 1 in 1,000. Being the right distance from a star, 1 in 10. Having the proper planetary mass, 1 in 10. Having the proper planetary spin, 1 in 10. Having the proper planetary tilt, 1 in 10. Having comet sweeping planets, 1 in 40. Not being near a black hole, 1 in 250. Having a large solitary moon, 1 in 10. Possessing a magnetic field capable of shielding, 1 in 10. But the odds of possessing all of them at the same time is 1 to how many zillions of zeros. Our solar system consists of 9 planets circling the sun. The sun is a star, okay? The 4 inner planets, including the Earth, are solid. The outermost planet, the next 4 planets are much larger than Earth, and they're gaseous. They're all made up of gas. But each one of them has a problem. Either they're too close to the sun, dynamically burns up and it's too hot. Or they're too far from the sun and they're too cold for Earth to be able to survive. The position that we're in is exactly the position for life to exist. Okay? Now, the Earth, so this is Florida. We're at the tilt. We're spinning. We have our northern hemisphere and our southern hemisphere. What kind of season do you think that we're in right here? This is tilted closer to the sun, okay? This is tilted away from the sun. So what season do you think this would be? Yes.
Summer.
For which, for us?
Yes.
No.
Winter.
Winter. Because see, we're tilted away. This is like the rotisserie chicken. It's close to the sun, okay? All right, see the tilt? The tilt is responsible for our seasons because this is hotter right now because it's leaning toward the sun. So when we're having Christmas up here, they're having summer, okay? Kind of interesting. Now, we're spinning, so so all of this southern hemisphere is getting nice and toasty warm. Okay, so now we're winter. Now we're gonna come here. Remember, we're spinning, spinning, spinning. This was winter. What do we turn into after winter?
Summer.
Spring. And they just had their summer down here in the southern hemisphere. So what are they gonna have?
Fall.
Fall. They're starting to get a little farther away from the sun now because of the tilt. Now we're gonna come over here. And now look, we're tilted. Here's Florida. I'm gonna move this way. Still see the tilt. Okay, I need it back on the other side. Yeah, oh yeah, okay, that matters. Okay, so now Florida's here, and now we're tilted toward, you see? We're tilted toward the sun. So what season are we in now? Summer. And what season would be the southern hemisphere? Australia is going to be having what? Winter. Now we come over here. Again, we're spinning the whole time. We just had summer, so now what are we going to have? Fall. And what is the southern hemisphere going to have? Spring. Okay? All right, so that's how the seasons work. Without this tilt, we would be messed up because we wouldn't have the angle of the area being closer to the sun. Life would not exist if it were not for this tilt. So we talked about the atmosphere, the moon, we talked about the moon, and the moon also is responsible for the tides because the moon rotates as well. And the moon, the earth rotates, and this is rotating, okay? And twice a day, usually in certain places, the tide will come in and tide will go out. And then the tide later will go in and the tide will go out, depending on the position of the moon with Earth. And then, of course, you see the moon in different phases based on how it's in relation with the sun and the Earth in between it. Now, Earth is unique in another way. And what is the most color that you see on here? Blue. I think when an alien would be coming by and looking at planet Earth, they would go, "Oh, look, that is the blue planet." They might say the blue and white planet, you know, because it shows our atmosphere. But our planet is unique in that it has water. Water is our most amazing resource, one of them. Without water, life on Earth would not exist. Part of the mantle is the lithosphere. This is the mantle. And the mantle is about 1,900 miles thick. Then you have the outer core, which is liquid, magma, or molten. It's liquid, iron, and nickel. No, that's not very well done. Okay. And then you have the inner core, which is solid iron. And it's about the size of the moon. Okay, now why do they believe this? They believe this because there is a current or a field that exists around Earth, and it's called the magnetic field. Let's talk about that. That's our next vocabulary. The shield from the Earth, that shields the Earth from harmful radiation coming in from the sun and the stars. Okay? Now I wanted to touch base on something else with this. Because this being hot, this thermosphere, burns up meteors and things coming from space that would harm us. So we have no idea how much we're protected by this thermosphere. All right? But in the same way, we're protected by the magnetic shield. The reason there's a magnetic field is because the Earth is spinning 1,200 miles an hour, and it's got molten lava that is swirling and swirling. And that creates an electrical current. We're going to be doing electricity and magnetism in this class, but we're going to learn that electricity creates a magnetic field. The movement of electrons causes a magnetic field, and especially spinning electrons create a magnetic field. And so you have inside of the Earth that magnetic that molten lava that is swirling and it's creating, the electrons are all moving against each other and it creates a convection current. And that current creates this magnetic field that goes out. Around Earth, this is what it looks like. Isn't that cool? Now remember, we're going around the sun, we're spinning, and it's creating this magnetic field around Earth. Here's Earth. And this is no accident. This is design, you guys. This is design. If we did not have all these things, the thermosphere and the magnetic field, we would constantly get bashed and get radiated. It would be terrible. Now, the crust. We're going to be talking mostly about the crust. But the crust is not one big solid ball. It's more like this soccer ball. Now this is, you know, obviously it doesn't have a lot of air in it, so it's depressed. Can't pull it out, but you get the point, okay? It's the continents are sitting on what we call tectonic plates. And the evidence for the tectonic plates is the earthquakes that happen in the areas where these plates are supposedly exist. This states that the Earth's lithosphere is made of several large, flat pieces that move. And that is called plates tectonics. It's the theory that they move. This shows some plates. And the reason they know this, the pink, it's hard to see. I wish it was a darker. I think it's interesting that one goes right through Israel right there. And then this one, that's why there's so many earthquakes in California. Just look at that plate, it's right there by California. And it goes all the way down to here. There's a tectonic plate through this. Does anybody remember what this is? Who knows what this is? Anybody that did oceanography with me last year? Yes. The Mid-Atlantic Ridge. Remember, we made a model of it. Okay? There's a plate there. There's earthquake activity in that area. And then over here, all the way down to here, all the way down to here. Here, it looks very interesting. A lot of it is oceanic. But this one causes all kinds of trouble. Okay? And then there's one over here. And if you look at the history of earthquakes, they're all right here. They're like, you can see these little dots where all the earthquakes, they're all like congested on those areas, which is why they believe that there are moving plates under there, okay? Now, scientists have long said that earthquakes tend to occur on these zones. That's where they happen. And they plot the earthquakes and they show movement of the plates through that. Volcanoes also tend to happen around these tectonic plates, okay? It's almost like looking at that globe and thinking of it as a jigsaw puzzle, all right? So, we're gonna do a little bit of study on the different types of earthquakes. First, let's get the definition of an earthquake. Number 10. The sudden and violent shaking of ground, sometimes causing great destruction as a result of movements of the Earth's tectonic plates or volcanic action. Now, if anybody gets this wrong on vocab in 2 weeks, I'm going to be the sudden violent shaking of the Earth. And gee, that's the mantle. Okay. So, that's what an earthquake is. Now, there are different ways that earthquakes happen. Okay? Here's the definition of a fault. Weakness in the rock strata that can shift and create an earthquake. An example is the San Andreas fault line in California. We just talked about. That's a fault line. Now, there's different types of shiftings. We're going to learn the different types of shiftings, and then we're going to shift them on these plates. All right? So let's do it. Number 12. The first type of shifting is a transform boundary. A fault where they slide past each other. The plates slide past each other. That's a transform boundary. Okay, a transform boundary. Plates slide past each other. And this would be an example. This type of a boundary is found in the San Andreas Fault by California. Found in San Andreas Fault. A fault where the plates move away from each other is divergent. So the plates move away from each other. Is everybody keeping up with me? No. Okay, and then our final one is the convergent boundary. These are going to be the fun ones for you to run and play. Plates crash or crunch, or one goes underneath the other, okay? Go to number 14 on your vocab. And that's the convergent boundary. Actually, this is kind of old. It's the Richter scale, number 15. They said they don't use it anymore. But it's similar in the design in that it is a numerical scale for expressing the magnitude of an earthquake on the basis of seismographic oscillation. We're going to do a little activity right now. Okay? The squeeze cheese represents the outer core. Okay? Molten rock and movement circling at more than 1200. It goes faster the farther it is inside. It spins faster. And it creates an electrical current which causes our magnetic field. Really cool. We're going to learn more about that when we do electricity and magnetism. Okay? So, that's your squeeze cheese. Now we have our mantle. Our mantle moves on top of the squeeze cheese. We are not stationary. You might think you're safe. You're not safe. We are all in God's hands every day because the ground underneath us is moving. You don't even realize it. Millions and millions of earthquakes every day that you don't even feel. All right? Because this is very plastic. See, it says, you probably can't see from there. It's plastic. It's movable. Okay? That's your graham crackers. That's what we're going to start with. So the first thing we're going to do once you've got them going the right way is we're going to make a transform boundary. So they would go like this. So I want you to move them like this. I already moved. Okay. So what we're going to do in this little container are 30 toothpicks and 30 marshmallows. What I want you to do is create a structure like a house or a building out of these materials. But we're going to see which ones will be able to survive an earthquake. Because we have bowls of Jell-O over here. And we're going to set them in bowls of Jell-O. And we're going to shake it like the Richter scale would measure an earthquake. And we're going to see if your structure survives. Now, if you look at a flat map of the world, you can see how it could be that at one time these continents were together as one. All of them fit together kind of like a puzzle piece. And that theory, very interestingly, is agreed on by creationists and evolutionists. All agree that at one time there was a massive continent, one massive continent, that was called Pangaea. And so we're going to try to recreate Pangaea, but let's first get the vocab word. Okay? This is number 16. The theory that states that all the present continents were once together and were collectively known as a supercontinent is Pangaea. Now, creationists believe that these continents were broken apart by the flood, by the waters coming up. Remember we said there were 6 quintillion gallons of water in the rocks, and the Bible says that the water came up from the ground and down from above. Creationists believe that it was the flood that broke apart these continents. Now, the interesting thing to prove that, we're going to talk more about this next time we come, is that there is fossil evidence to prove that at one time all of the land masses were covered with water, because there are fossils of sea creatures on the top of mountains. So how did they get there if there were not a global flood? So it certainly fits. But an evolutionist will tell you that it happened over millions of years with the movement of the tectonic plates that are causing what's called continental drift. So that is number 17, continental drift. Now we see this happening today. So the uniformitarianism theory says that if it's happening today, that's how it always happened. So if the continents are moving apart at a very slow rate, evolutionists will tell you it took millions and millions of years for them to fall apart, to come apart. But under the catastrophic theory, it could be that it was the flood that caused them to break apart. Now we're going to do 2 things for the rest of this day. One thing is that you are going to get a blue sheet of paper, and I want you to piece together these continents like a puzzle to make Pangaea. Then we're going to turn these on. Then we have milk in here, which is representative molten, part of the mantle. Then on top, we're going to sprinkle a layer of cocoa. And then we're going to turn it on and heat it up, and we're going to eventually see that heat will move